guys. So, numerical values mean the actual numbers. So they gave us the numbers, but sometimes they'll just say, what do the numerical values of the equation mean? And that means you have to tell them what the numbers represent, okay? So here, if I want to explain, I would say the 160,000 represents what? Initial amount of what? So the university population. Of a country in 2012. You have to explain it thoroughly. You just can't say it's the initial population or the initial value. That is not enough. You're actually going to get no marks for that. So it represents the university population of a country in 2012. You could say the initial population in 2012 as well. Then what does the 1.045 mean? It means the population is doing what? Is increasing as it is greater than 1. And so you have to explain that it's increasing as is greater than 1, right? That's the key thing. And then 1.045 minus 1 equals 0.045 times 100 equals 4.5%. So the population is increasing by 4.5% per annum. Always one because it starts at 100. So we want the population in the year 2015. What does that give me? N equals what? 2015? Does N equal 2015? No. 2015 minus 2012, so it equals 3. And how do we know that? Because sometimes N is 2015. Sometimes N is something else. And the reason why we know that is it says country is a function of the number of years N since 2012. So N represents the years since 2012. That's why it's 3, right? Not 2015. So you have to read. So it gives us P equals 160,000 bracket 1.045 to the 3. Which is 182,580. Actually, 86. So in the year 2015, the population was 182,586. And you'd have to write that. In the year 2015, there were 182,586 different people. Determine the number of years required to the nearest year for the population to double from 2012. So we're going to have a final at 320,000 equals 160,000. Bracket 1.045 to the n. What do we have to do next? Divide by 160,000. What do I have to do when I don't know the exponent? Convert it to a log. So I get log base 1.045 of 2 equals n. N equals 16 years. And then you need a sentence. You'll say it takes 16 years for the population to double from 2012. You get 0.3? Are you pressing the math arrow up button and using the log button?
I'm using the log button.
Not the log button. Math, arrow up, and use the actual log button. Okay, you're not pressing. Go log 2 divided by 1, So, the number of fish in a lake is decreasing by 5% each year. So the key thing here is it's decreasing by 5%. To be honest, they don't give the big sentences when they ask what does the value mean. Like I literally told you what the sentence, in the sentence, what the values mean already, right? Like I'm pulling up more information and I kind of gave you the information to begin with. So I'm asking you, what does the 0.95 represent in this case? Well, it means that the number of fish, it means this. The number of fish in a lake is decreasing by 5% per year. And how do we do that? We do 1 minus 0.95, which gets us 0.05 times 100, which equals 5%. So we show the algebra that gets us there. If it's below 1, it's decreasing. If it's above 1, it's increasing every single time. Then here it says there were 2,500 fish present in June 2012. How many would they expect in 2017? So this here represents NO. And I can't say initial because they gave me a variable that isn't an I. And then they want to know T equals 2017 minus 2012, which is 5. And they want to know N of 5. So we do N of 5 equals 2,500, 0.95 to the 5. Which is 1,934 fish. And you have to write a sentence. So you would say, in June 2017, one would expect that there would be 1,934 fish present. Then it says, how many years to the nearest tenth would it take for the fish population to reduce to half? So N of T would be 1250. The rest would stay the same. So I would get 1250 equals 2,500, 0.95 to N, divided by 2,500. 0.5 equals 0.95 to the n. And when I don't know the exponent, I have to convert to a log. So I go log base 0.95 of 0.5 equals n. 14. For saving example 4 for the next day, go flip back to the very front of, flip back to the front of your, yeah. All right. Log laws are on your formula sheet. It basically says that if you have the same base and you add two things, two logs to the same base, and the key thing is that they have to have ones in front. So this is a 1 in front, and this one has a 1 in front. And when they have positive ones in front, you can actually put them together by multiplication. If it has a positive 1 in front, it can go to the top for multiplication, and a negative 1 in front, it can move to the bottom for division. So we're going to talk about the two of these. So if I actually type this into my calculator, type in log base 2 of 16 plus log base 2 of 8. Now you technically wouldn't even have to type them into your calculator, because what is your calculator doing to get this? It's saying 2 to what power is 16? Well, that's 4. So if I typed in log base 2 of 16, it would be 4. Plus 2 to what power is 8? 3. So I actually get 7 when I type this in. Then when I take the two of them, because they have plus 1s in front, this one has a plus 1 in front, and so does this one. So I can put them together by multiplication. When I do that and you type that into your calculator, you get, bless you, 7. It's the same answer. That's why it does work. So if we look at these ones with subtraction, if I go log base 2 of 16, it's 4, minus log base 2 of 8 is 3, and I get 1, correct? And I told you if it has a plus 1 in front, this goes in the numerator, and if it has a minus 1 in front, this goes in the denominator. But they have to have the same base. You see how this one has a base 2 and this one has a base 2? We can't put them together unless they're the same base. So when you see a whole bunch of logs with the same base number, think, put me together every single time. I need to put these together. I need to put these together. So when I do this, I also get 1. So those are with numbers. So we're going to do a few with numbers, then we're going to do a few with variables. Because if they're just numbers, could you not just type them in? Yeah. So they're going to make it with some variables. So in order to use that rule, I have to have plus or minus 1s in front. So if I look at example 1, evaluate the following. This one has a plus 1 in front. This one has a minus 1 in front. And this has a base 2 and a base 2. So can I put them together? They have to have 1s in front and same bases. Do they currently have that? Yeah, so I can put them together. I can go log base 2. Anything with a plus 1 in front goes in the numerator. Anything with a minus 1 in front goes in the denominator. So this has a plus 1 in front. You see it? So the 12 goes in the numerator. This one has a minus 1 in front. So the 3 goes in the denominator. So what are we going to get? Log base 2 of what? What's 12 divided by 3? 4. We don't need our calculators. 2 to what power is 4? 2 to what exponent is 4? 2. So the answer to this will be 2. Because every time you type this into your calculator, that's all it's doing. 2 to what power gets me this? Could you just type it in and get an answer? Sure. That all is just numbers, so you can type it in. B. What is the base of all of the ones in B? 6, 6, 6. So they all have to be the same base, which they are. And then what do I need to have in front of them? Plus or minus 1s as their leading coefficient. So I have a 1, I have a positive 1, and I have a negative 1. So I'm going to have two numbers that appear in the numerator and one in the denominator, correct? Anything with a plus 1 in front goes to the numerator. Anything with a minus 1 in front goes to the denominator. So I get log base 6. Where does this 7 go? On top, because there's a plus 1 in front. Where does the 8 go? In the numerator. When I have two numbers in either the numerator and the denominator, I will multiply them. Do you think they'll have the oopsie to you adding them there? They will. And then the 2 has a minus 1 in front, so where does it go? The denominator. So then I'm left with log base 6 of 56 divided by 2, which is log base 6 of 28. And then we can leave it there. So you might just be testing whether you can reduce it down. What's the catch with these ones? Pardon? The base, there is base. What is the base? X. So is that the same base? Technically, yeah, they're all x's, correct? It's just forcing you not to be able to plug it into your calculator. So you have to use rules. So write this as a single logarithm. Okay, so I have base x, base x, base x, base x, so that's good. What, I have a problem here though, I have a bracket. Can I distribute and get rid of the bracket and then be in the same boat as I was before? Yeah, so let's try that out. So we get log base x of 10 plus log base x of 75. And the minus sign has to distribute through. So then I get minus log base x of 2 minus log base x of 3. No, you're distributing the minus sign through. So now I have 2 of the logs with plus ones in front and 2 of the logs with minus ones in front. So the ones with plus ones will go to the numerator and the ones with minus ones will go to the denominator, right? And what's my common base? X. So I get log base x, and then I'm going to get a fraction beside it. Whatever's plus ones goes in the numerator. Whatever's minus ones in front goes to the denominator. So I'm going to get a 10 in the numerator times a 75 in the numerator, because they're both at plus ones. And then negative 1, I'm going to get a 2 times a 3. So I end up with log base x of 750 over 6. So try and reduce it. Do 750 divided by 6. Math enter, it'll do it for you. Or you could say, hey, I could take a 2 out of each. Or it works out to just what? What's 750 divided by 6? 120. So if you don't know the rules, are you ever getting to log base x of 125? Can you type your way into this situation? No, there's no numbers. You have a variable in there. So you need to know your rules. Okay, these should all have brackets around them. That's my fault. So this should have a bracket, this should have a bracket, this should have a bracket. So I want you guys to try this one out. You get about a minute. So we have log base 2, log base 2, log base 2. When they're all the same base, it should scream, put me together. Because if they're all the same base, that's what they're going to want you to do. This has a plus 1 in front, plus 1 in front, minus 1 in front. So I know 2 are going to go to the numerator and 1's going to go to the denominator, right? It's not like there's no tricks to this. Literally, that's all it is. So we get log base 2, and then this one has a plus 1 in front, so x goes to the numerator. This one has a plus 1 in front, so 2x goes to the numerator. And what do I do with when I have more than one item? Multiply. And then the x squared is a minus 1 in front, so it goes to the denominator. So we're actually left with log base 2. X times 2x is 2x squared over x squared. The x squareds can cancel. And I'm left with log base 2 of 2. What does that equal? 1. Because 2 to what power is 2? 1. Or you can type it into your calculator and it gives you 1. Either way, we're trying to match their multiple choice answer. All right, now we're going to flip over. All right, so here it tells us log A equals 6, log B equals 3, log C equals 2. Determine the values for A, B, C, and D. So these are not multiple choice, these are actual questions. So if I gave you log AB and I told you that log A equals 6 and log B equals 3, the only way you can plug those in is if you have a log A and you can put in 6 and you have a log B and you can put in 3. So sometimes we put them together like we've just done, we made them all be a single log, but sometimes we actually have to pull them apart. So these are being what? The A and the B are being multiplied. Do you see that? So I'm going to make a big point of the fact there's a multiplication in there. I'm going to show it like this just so you can see it. Log A times B. They're both in the numerator, aren't they? So we can actually separate them with plus ones in front of them, can't we? So these ones are together, we can pull them apart. So sometimes we want to have a whole bunch of logs and we want to put them together. But what everyone forgets is sometimes we have a full log together and we want to be able to pull it apart. So when I pull this one apart, I get log A plus log B. Now are they in a form that I can actually do math with? Yeah, log A is what? The same as? What does it say up there? 6. So you can take this log A, huck it across the room, and replace it with a 6. Plus sign, log B, I can take it off the board, throw it away, and replace it with a 3. And my answer is 9. What is the difference with B? Division. So we're going to end up having a what? A positive one and a negative one. Exactly. The one on the bottom gets the negative one. And if you have more than one thing on the bottom, then you have 2 negatives. Yeah?
What you do with the logs on that?
They got completely replaced. Log A is 6. Log A is 6. Right? So the log A gets thrown away and it gets completely replaced with 6. So here I'm going to have log A minus log B. And log A is 6, so I replace it. Minus log B is 3, and 6 minus 3 is 3. You try C and D. Give you a minute. So we have log A, B, and C. Do you see how people might not spot that those are all multiplied? Like right now you do, because you're in the lesson where I'm teaching you an example where you have been separating them and they are multiplied, correct? So it's more obvious. But what I do when I have more than one thing multiplied is I will put in multiplication dots to remind me that those are multiplied. And these are multiplied as well, right? The B and the C are actually separate. So these all have plus ones in front because they're all numerators. So log A plus log B plus log C. So I'm going to get 6 plus 3 plus 2, which equals 11. And then D is log A, then what B and C? Minus log, and some people say, can't I just put log B and C together? Sure, but is there an answer for BC together with a log in front? No, so you have to separate them in order to plug back in. So we're going to get minus log B minus log C, and then log A is 6 minus 3 minus 2, which is 1. So we're going to practice a few of these, and then we're going to go over what happens when we don't have plus or minus ones in front. What happens if there's a 2 or a 4 or a negative 1, or I guess negative 1's fine, or a 6 or whatever. There's one little step we have to do, and then we can just do exactly what we did. So we're going to talk about those in a second. But for right now, I want you to do this one, and this one. Go. So the rule is, if they have the same base, and have plus or minus ones in front, you can put them together by multiplication and division. It's a formula on your formula sheet. So, if this one has log base 6, log base 6, log base 6, we're already getting there, correct? All the same base, which is what we need. Then we need plus or minus ones in front. This is a plus 1 in front. I can't see what the heck this one is. Thanks, little box. Is it a plus? Plus 1 in front. And then this one is a minus 1 in front. If it has a plus 1 in front, it goes in the numerator. If it has a minus 1 in front, it goes in the denominator, because minus 1s make a division and plus 1s make a multiplication. Okay? So we're going to get log base 6. That doesn't change. Anything with a plus 1 in front goes in the numerator. Anything with a minus 1 in front goes in the denominator. So the first one has a plus 1 in front, 8 goes in the numerator. Next is a plus 1 in front, 4 goes in the numerator. The next one has a minus 1 in front, so the 6 goes in the denominator. If I have more than one item, I multiply. So I'm going to get log base 6 of 32 divided by 6, which they might reduce to log base 6 of, if you get 2 out of both, 16 over 3. 10. So the key thing here is, has to have the same base. If you had a log without the same base, you couldn't put it with the rest of the logs. You'd have a log just sitting by itself. And then the other ones put together. So if I had like log base 3, log base 3, log base 2, log base 6, I could only put the log base 3s together, and the other 2 would have to be separate. So what bases do these have? If there's no base, what is the base? 10. So I always, if my log doesn't have a base, I will always go and put in tens. Because if I physically write 10 3 times, I hope it reminds me to put them together, right? Like if I'm physically writing a 10 out a whole bunch of times, it screams, I have the same base, put them together. So this has a plus 1 in front, plus 1 in front, minus 1 in front. So I'm going to get log base 10. The 2 goes in the numerator, plus 1 in front. The 10 goes in the numerator, plus 1 in front. Get a multiplication symbol. And the 1/5 goes in the denominator. Then when I type them into my calculator, I'm going to get log base 10. When I go 2 times 10 divided by a fifth, not the log part, just 2 times 10 divided by a fifth, I actually get 100. And then log base 10 of 100 is 2. So this one actually works out to something nice. More often than not on a test, they'll have variables. Yeah. When a log doesn't have a base, it's base 10. Yeah, just like when a square root doesn't have an index, it's a 2. Yeah. And with logs, it's just a 10. Yeah. So now this one's going to be base 10 again, base 10 again, base 10. And this has a plus 1 in front, minus 1, minus 1. So I'm going to get log base 10 of 25 in my numerator, and then in my denominator, I get a half times 5. So I can physically type that into my calculator. I can go 25 divided by 0.5 times 5, close bracket, and it tells me it's 10. Like I don't have to, my calculator literally does math for me. It tells me it's 10, okay? We'd be like, where'd you get 10 from? Here, on my screen. I just typed in what's in the brackets, right? So I get log base 10 of 10. What's the answer to log base 10 of 10? 1. Whenever these are the same, it's just log 10 divided by log 10 technically, which is 1. Now what happens if I don't have a 1 in front? Well, there's this other rule. So for log laws, there's 3 of them. This is your formula sheet. There's the multiplication law, the division law, and then this is called the power rule. So with a log, and only if it has the word log, I can actually move whatever number's in front. I can move it to the exponent, if that's helpful, or I can move from the exponent and put it completely in front of the log in front. They actually are the same thing. Now, if you don't believe me, look at this. So if I go log 2 plus log 2 plus log 2, I could technically put these together as log base 10 of 2 times 2 times 2. If you type this into your calculator and this into your calculator, they're the same. We've already talked about this. Now this is the same as log base 2 to the 3, is it not? If I drop the 3 in front, that would be the same as 3 log base 2. What happens when I add a log base 2 plus a log base 2 plus a log base 2? What do I get? 3 log base 2s, don't I? So these are actually the same. So if I have the number as the exponent, I can drop it in front on a log, or I can take it from in front of the log and put it as the exponent. And sometimes it's more helpful to have it in front, and sometimes it's more helpful to have it as the exponent. It just depends on what I'm asking you. If I'm asking you to write something as a single logarithm, it's better to put it as the exponent because I can't put them together unless they have plus or minus 1s in front. So let's practice with this one. Write the following in the form log b m to the n. So I bring the 2 and I drop it up here. So I'm going to get log base 3 of x squared. Now this one has a negative 1 in front, which really wouldn't affect me, but could I take it up to a negative 1 if I wanted to? Do I have to when I'm trying to put them together? Plus 1s and negative 1s are totally fine. But I could also bring it up, which I will never do. But I'm going to prove to you that I could. I could bring this up as a negative 1. I could bring this up as log x to the half. I could make this be log base 6 of 2 to the 4. All that you need to know is you can take the numbers in front of logs and you can bring them up to exponents. And why is that helpful? Because I can't put them together unless I actually have ones in front, right? So let's look at example 5. I have 3 log base 2 of p minus 3 log base 2 of q. Now what I see here is a base 2 and a base 2, which screams to me to put them together, correct? When they're the same base, it screams, put me together every single time. Put me together, put me together, put me together. Okay? But I can only put them together if they have ones in front. Currently, what do they have in front? 3s. So I don't take the signs with, I only take the number up. So I'm going to bring the 3 up here and make this a p cubed. I'm going to bring the 3 up here and make this a q cubed. Do you see how I don't take the negative 1 with? I just take the number, not the negative sign. I'm just bringing them up as the exponent. So now I have log base 2 of p cubed minus log base 2 of q cubed. Okay, I didn't do anything crazy. I just put a number in front and put it onto the thing that's in the bracket. It's an exponent. Can I now put them together? Do they have the same base? Do they have plus or minus 1s in front? Yes. So now I can put them together. So I'm going to get log base 2. And in the numerator, I'm going to get p cubed, because it's positive 1 in front. And in the denominator, I'm going to get q cubed, because there's a negative 1 in front. Now it says I can replace p over q with 8. Do I technically have p over q currently? I have p cubed over q cubed. Could I take the 3 and put it outside of the bracket? Can I take a 3 of both of them and put it outside? Yeah, I could go log base 2 of p over q cubed. Could I not? When they're both to the 3. And what did it say p over q equals? 8. So I can put an 8 in for this. Can I not? P divided by q equals 8. So I can take the p divided by q, throw it out, and replace it with an 8. So I can get log base 2 of 8 cubed. Type it in your calculator. And you should get 9. You have to put in brackets. No, remember we go log 8 cubed divided by log 2? Every time we have to do that? Yeah. I want you guys to try example 6, ABC. ABC. Okay, so this one is log base 2 of p, log base 2 of q, both base 2, and 1's in front. So this one's easier than the previous one. We can put them together. We get log base 2, because there's a plus 1 in front, p goes in the numerator. Because the minus 1 in front, q goes in the denominator. And I could take out pq and replace it with 64. So I can make this be 64. So I get log base 2 of 64, which equals 6. Then we're flipping over. Okay, these have 4's in front, which is a problem, but I can bring the 4 up here, and I can bring the 4 up here. So now I have base 3, and plus 1's in front. So I get log base 3 of a to the 4 times b to the 4. They stay in the numerator. The problem is I can only replace an ab, so I need to rewrite this as ab to the 4. Then instead of ab in here, I can replace it with 81. So I actually get log base 3 of 81 to the 4, which equals what? 264, something, I don't know. What is it? Okay. 16?
16, yeah.
I think he put the 4 outside the bracket. Yeah. That's what I did in the first one. I got it wrong.
Well, let's go 81 to the 4. It might not be wrong. No, it's not. 81, the 4 is outside.
Oh,
The 4 is outside the bracket. So we log 81.
So I was right the first time.
Divided by what?
And then she put the answer.
No, it's still 16.
Oh, you were right, Cole.
Yes.
Even if you put it inside, it's still 16. I don't know what you did the first time.
I put it. What I was saying is I put it outside the first time.
Oh, outside the whole thing?
Yeah.
Ah, that might be what you did. On this one, I have to do.
I didn't even though, because I was right. So actually, well, no.
Okay.